This is a short video about the pH values of neutral solutions and relates to Kw, which is the ionic product of water. We're going to look at it now. The definition of a neutral solution is where the concentration of H plus ions in the solution equals to the concentration of the hydroxide ions in the solution. And it just happens that at 25 degrees C, these two multiplied together is 1 times 10 to the minus 14 moles squared decimeters cubed minus 6, which is the ionic product of water. So we can actually work out the concentration of H plus ions at 25 degrees C by taking the square root of this. So the square root of 1 times 10 to the minus 14 is 10 to the minus 7. So that's the concentration of H plus at 25 degrees C. And we take the minus log of this, we get the pH, which happens to be 7. So at 25 degrees C, because Kw is this value, we have pH to be 7 for neutral. So the ionization of water is affected by different conditions like any equilibria. So bond breaking, so breaking the OH bonds in water, is endothermic. So we know that we need to put energy in to break bonds. And the reverse process is exothermic. So if we increase the temperature, it will favour the forward endothermic process, and we have high concentrations of H plus ions and OH minus ions. So if that's the case, the ionic product of water, which is H plus concentration and OH minus concentration, which is the same as H plus concentration squared, because these two concentrations must be the same, because every one of these gives us equal numbers of these for each one molecule ionized. So that gives us a value of 1.008 times 10 to the minus 4. It's not exactly 1 times 10 to the minus 4. We use 1 times 10 to the minus 4 to simplify the number, but it's actually more accurate to be this number. As we said, if we put the numbers in H plus concentration to work out pH, so what I've done here, I've just square root this value because this is H plus concentration squared. If I square root this value, I get H plus concentration, and if I take the minus log of H plus concentration, I get pH, and that's pH 7. So as we said, if we increase the temperature, the equilibrium shifts to the right hand side. These are going to increase in concentration, and in fact Kw would increase in value. So here's the value of Kw at 50 degrees C. So at high temperature, the equilibrium has shifted to the right. These two concentrations have increased. So the product of these two numbers, or these two concentrations, is going to be bigger than at 25 degrees C. So it's in fact about 5 times bigger. So if we work out the H plus concentration from this value of Kw, because we know Kw is concentration of H plus ions and hydroxide ions multiplied together, and since these two concentrations must be the same for water ionizing, we can simplify it to H plus concentration squared. So if I take the square root of this value, I'm going to get H plus concentration, and if I plug it into minus log of H plus concentration, I get the pH. You can see that the pH is actually a different value to 7, so it's no longer at 7. This doesn't mean it's not neutral, and it doesn't mean it's acidic. It just means that the neutral pH at 50 degrees isn't 7, it's actually 6.6 at high temperature, because the equilibrium shifted towards the right hand side at high temperature, meaning that the concentration of these two have increased, and therefore Kw is a bigger number, and working out H plus concentration from Kw will give us a different value to pH. So here we've got a question to work out the pH of sodium hydroxide at 50 degrees C, and it will work out different to what we expect at 25 degrees C. So normally we get questions to work out pH and we assume that it's at 25 degrees C, but at different temperature, be aware that it would be a different value because of the fact that Kw is different. So have a think about how you would do this question before I give you the answer. So we start off with Kw as this expression, and we can simplify this expression as H plus concentration squared. So what we do is we can work out H plus concentration by using the pH at 50 degrees C. So we can work out the Kw value at 50 degrees C by the pH of pure water. From this, we can work out the H plus concentration. So what we do is this, we go 10 to the minus pH is H plus concentration at 50 degrees C. So we therefore have 10 to the minus 6.63. And if we use a calculator to do that, it works out to be 2.34 times 10 to the minus 7 moles per decimeter cubed. So what we do, we then substitute this value into the Kw expression as H plus concentration squared. So this gives us a value of Kw. To work out the pH of an alkaline, we use Kw to work out the H plus concentration as follows. So what we do, we substitute the value of Kw here into this equation, and we know the concentration of the hydroxide ions from the question, and we work out the concentration of H plus ions and then put that into minus log to the base 10, and we work out the pH. Okay, we can cancel out the units as well, and we get this value, and then we plug it into minus log of H plus concentration to work out the pH, and we get a final answer to be 12.3.